Right, so an impromptu thing on chapter 21. Hopefully it will help a bit. I've pulled a lot of the questions I'm going to do now, so a lot, I'm only going to do a few, but from the review notes for chapter 21, the review notes for electrochemistry. So let's look at this one. A spontaneous electrochemical reaction. Well, if it's spontaneous, the way we say that is we're looking down here, right? Q is 1, that's our standard state. If it's spontaneous to the right, which means K must be over here. So K has to be greater than 1, so that means we can eliminate C right there. We also say that if it's spontaneous, delta G0 is less than 0. Spontaneous to the right, delta G0 is a negative, so that means we can eliminate A, D, and E, so we're left with A and B. Okay, now the way we've got it with E0 is if E0 is a positive number, it is spontaneous. That is the convention we use for the sign. So a spontaneous electrochemical reaction, delta G less than 0, K greater than 1, that's spontaneous for any reaction, and for electrochemical where we bring in E0, E0 greater than 0. Right, question 46. Value of E0 for this cell is 1.59. What's delta G0 for the reaction? Well, I wanted to do this one just to show you how you go from the cell notation to what we're interested in. If you remember when we set up the cell notation, this describes a voltaic cell separated by the two lines, the anode from the cathode. So we can immediately go from this to the oxidation and reduction half equations. By definition, anode is the oxidation, cathode is the reduction. Now the way we do it is, first of all, that little line there, and it might be a comma sometimes, that is instead of the arrows. So let's get rid of that and put in the arrows. And then of course for any half equation we need to add in the electrons. Chromium 0 to 3 plus. That's going to be, actually, excuse me, before we do that, with the reduction, we need to balance the important atoms. We got 2 mercuries, so we need 2 mercuries. Okay, now we can stick in the electrons. We got chromium to chromium 3 plus 3 electrons. Each mercury goes from 1 to 0. So 1 electron per mercury, but we have 2 mercuries, so we need 2 electrons in the reduction, 3 in the oxidation. Okay. Now when we look at that, how many electrons are going to be transferred in the reaction? Well, it's not a one-to-one, is it? Because every oxidation produces 3 electrons, but every reduction only uses 2. So the N, the number of electrons in the reaction, is going to be the least common multiple of 2 and 3, which is of course 6. So E0, 1.59, N is 6, plug it in, delta G0 minus NFE. We did this in class, not this particular one, but we did a couple of examples. Minus 6 times 96,500 times 1.59, and that gives us minus 921 kilojoules. Calculate the value of E for this cell, right? Well, again, we got cell notation, but notice how I've stuck in the concentrations in the cell notation. Okay, well, let's see how we can interpret that. First of all, on this review sheet, you're given at the very start a table of E values. So we'll go for that. We're looking for copper and copper 2 plus redox couple, and the silver plus silver redox couple. So we find those. Silver plus an electron goes to silver, plus 0.8, and copper 2 plus 2 electrons goes to copper, plus 0.34. Okay, so analyzing this half equation the same way we did the last one, we can just go straight from it to the oxidation and the reduction half equations. The oxidation, copper going to copper 2 plus, need 2 electrons. The reduction, silver, the cathode, so the reduction, silver plus goes to silver, plus an electron. Put in the potentials. The copper, we're going to have to flip it because it's an oxidation, so it becomes minus 0.34. The silver, of course, straight the reduction, the 0.8 and the 0.8. So this gives us both E cell is 0.46, and when we look at the whole thing, we say that, of course, N is 2, because I've got 2 electrons in the oxidation, only 1 for the reduction, so it's going to be 2 electrons moving around. We have to, of course, balance the equation. Cu plus 2Ag plus goes to 2Ag plus copper 2 plus. Hope I'm not going too quickly. Q, of course, comes straight from this. The copper and the silver are solids. We don't include them. Ag plus, Cu2 plus ions in aqueous solution. So therefore we have the copper 2 plus over the silver plus squared. We know those concentrations. I told you the concentration of copper 2 plus was 1 molar. That goes there. Concentration of silver plus 0.001 molar. That goes there. Throw it all in. Q is 1,000,000. Now we plug everything in. E equals E0, well we figured that out, 0.46 minus RT over little n, 2 times F times natural log of Q, we figured that out. Drop them all in. Wow, that was a long one dropping in. I kind of like that as it came in. So we get minus 0.46 minus 0.18, E is 0.28 volts.